Hello everyone. In this video we are looking at solving by factoring. Our objectives are to solve quadratic equations by using the zero product property, to write a quadratic equation given its solutions, and to solve real-world applications involving these quadratic equations. So let's begin. I want to share with you this little statement made by a gentleman named Michael Roos. He is actually a philosopher, a Darwinian philosopher, meaning that he poses ideas, theories about Darwin's evolution statements. And he said, why should a bunch of atoms have thinking ability? Which, if you believed in evolution, why would they suddenly, these atoms, have the ability to think? And he goes on to say that no one, certainly not the Darwinian as such as he is, seems to have an answer to this. So he doesn't know. He doesn't know why man should have these wonderfully complex abilities. See, humans have the ability to think. They can reason. We also have the ability to hold beliefs and to discern right from wrong. And he says that he has no idea why humans, based on his understanding of how things came to be, he doesn't understand why. But I know that it was for an incredible purpose. See, we've been given these abilities by God. He created us. He stitched us together with these abilities so that we can carry out His purpose. And that is to make Him known and to glorify Him. So, reflecting on that, I just want to share this verse from the book of Psalms. It's chapter 139, and it says, "Thank you for making me so wonderfully complex. Your workmanship is marvelous. How well I know it." And that's, I think, part of why God made us so complex, is so that we could just give Him glory, give Him praise, because He is an incredible creator. And knowing that He is so incredible and He's given us these abilities, we should not just let them sit idly, but try to exercise them and become more proficient with our abilities. And so as we move forward with this factoring and these challenging mathematical concepts, let's remember that God gave us the ability to do so. So we have another definition for this chapter, and it is that of a quadratic equation. A quadratic equation is written in the form ax squared plus bx plus c, and that is all set equal to 0. And those letters a, b, and c, those represent real numbers, but a, once again, cannot be equal to zeros. So slightly different from a quadratic function where it is all set equal to a y value or a function value, and you have lots of options for x, and they'll give you all kinds of different outputs for y. For this, we have very specific inputs because our only output is 0. So let's begin with discussing the zero product property. This is going to maybe seem a little confusing. I'm going to show you step by step. So if the product of two numbers is 0, then one or both of the numbers is 0. In other words, if you have two numbers, let's say they're p and q, and they equal 0 when multiplied, product multiplied, well, then we know that P or Q has to be 0. let's say that p is 0. Then 0 times q equals 0, and that makes sense. Or you could have q being 0, which would be p times 0, and that gives us 0. Or you could have the third case, where both of them are 0, and, well, 0 times 0 is 0. Ladies and gentlemen, if you are taking two numbers and multiplying them together, and it results in 0, of course one, the other, or both of them had to be 0. So that is our zero product property, and we're going to apply it all throughout this lesson. In this first example, we're going to solve. We're going to solve for x values that will give us that output of 0. So let's get started. To do so, we would factor our trinomial. And I'll give you a moment to do so. Why don't you pause the video and try to factor that using the methods that we've studied. This is going to be a x factor that you need to use. All right, so now that you've used that x factor to separate that, it would be x plus 6 and x minus 4. Those are your two factors. Notice what we have here. Two things being multiplied together and they equal 0. So each of these factors could be 0. Think of them as p and q, remember? So that would mean that either x plus 6 is 0 or x minus 4 is 0. And let's solve each of those for x so we know what the actual value of x would be. That would be a -6 or a 4. These are the two values that, when plugged into your equation, give you that output of 0. We have just solved this equation. We could check it by taking those values and plugging them in. So plugging in -6 into your equation, you would just, you could either do that in your head or with your calculator, and that is in fact equal to 0. You could also plug in the 4 into your equation, and that would be 16 plus 8, and that gives you 24. Minus 24, there you have it, is 0. So that is our first example of solving. Let's look at another, slightly different here. What is changed? 3x squared plus 6 equals -11x. Well, the issue is that it's not written in that form that we saw for our definition. We need to move everything to one side so that it is set equal to 0. Now that we've done that, we can factor our trinomial. And again, this is going to require that x factor, the longer one, because our a value is 3. So pause this video and take a moment to do so. You would have, sorry, that's the same thing, but you would have then expanded that middle term, the 11x, to a 9x and a 2x. Then grouping, you would have been able to factor out a 3x from the first two and a 2 from the last two. Notice that they both have that common binomial factor, so we will factor it out, and what is left is 3x plus 2. This is where we apply the zero product property and set each of those factors equal to 0 because their product was 0. That would mean that you had an x value of -3 or an x value of -2/3. Those are your solutions for this quadratic equation. I have a third example here. This one is yet again just slightly different from the previous. Notice that there are only two terms and they're set equal to one another. Well, we again want this to be in more of a standard form. That would be 6x squared minus 8x equal to 0. But what we have here is not a trinomial, we just have a binomial. We can factor it, I'm sorry, it's not a trinomial, it's a binomial. I'll make that little correction there. We can factor out just a GCF. And in doing so, we now have two linear factors. They couldn't be factored any further. So we set each of those equal to 0. We're applying that zero product property. And that means that you could have x being 0, because 2 times 0 is the only way to get 0. Or you could have 4 over 3 as your x value. So in this final example, we are looking at doing something kind of different. We are going to actually write a standard form quadratic equation given that its solutions are -1/2 and 3. So those solutions, those x values, when they are set, after we've used the zero product property, are 1/2 and 3. So we're going to write each of these solutions in that form where they are set equal to 0. So that would be, if you you're told that your x is 1/2 and your x is also 3, we would want to multiply each side by 2 and then subtract 1. So now it's in the form ax plus b. So far, so good? You wouldn't want it to just multiply by the reciprocal, because then you'd have a fraction for a, and a has to be a whole number. So you want to take your fractions apart like I just did. Now this other one, a little simpler. All we do is subtract 3. In our next step, we're going to use the multiplicative, that's a fun word, property of equality. We're told if p equals 0 and q equals 0, then p times q equals 0. So we'll set each of those factors equal to 0. Then we'll apply our distributive property to produce a quadratic equation. If you use that, or you think of it as foiling, you would have 2x squared minus 6x plus x minus 3, and that reduces to 2x squared minus 5x minus 3. And ladies and gentlemen, that is all for today. Thank you for your attention.